Hello everyone. Yesterday we will see how to download Xilinx Vivado latest version or old version. Today we will see how to run Verilo code in Xilinx Vivado. So go add source and click add and create design sources. Click next and create file and give any name to your file. Today I will show how to write Verilo code for D flip-flop. So I will give DFF. Click OK. This name is already I used it in before projects. So click DFF RTL, click OK and finish. Here you will give input and output ports. Let's assume clock as input and reset and reset and D and then our output will be Q. So click this and click output. If you have more number of inputs and output, so you can expand by clicking add. So below for D flip-flop, I hope you are already known some basics about digital electronics and flip-flops is sequential circuit. We used to store some random binary digits. It's only single digit and Q bar give output and then click OK. Now in design source you will see there is one file created. Here you can edit your input output also, and then I hope you can learn some basics Verilog. So before going to this video, so learn some basics about Verilog programming and we will write our coding for D flip-flop. So D flip-flop is nothing but if Q is nothing but if reset is 0, whatever the input in D, it will go to Q, and Q bar is nothing but inverter of Q. If Q is 1, Q bar is 0. If Q is 0, Q bar will be 1. So we will write our procedural block. So always at passage clock. Always at passage clock means positive edge clock. Begin. If reset is 1, begin. If reset is 1, begin. Q equal to, it's nothing but non-blocking assignments. For procedural block, we use non-blocking assignment. Q equal to, if reset is 1, Q equal to 1 bit binary. Q equal to, use non-blocking assignment. Q equal to 1 bit binary 0. I already told Q bar is nothing but inverter of Q. So here Q bar is 1 bit binary 1 end. Else begin if our reset is 0. Reset is 0 means Q non-blocking assignments Q equal to D. Whatever in D, it will go to Q. So Q bar is nothing but greater than or equal to non-blocking assignment toggle Q, and then N for every begin N for this begin we will give another N. So now why here show errors means procedural assignment to non-register Q bar is not permitted. So here I already told you know some you already know some basics about Verilog. For input, we must write as wire. So we will write wire. Sorry, for output, we will be rich because yeah. Now there is no error in our RTL code. So simply click and save the file. So now our RTL will be created. So next we will test this D flip-flop by creating simulation source. So again go to add source and create simulation. Click next. Click create file and then DFF TB test bench. TB is nothing but test bench. Click finish. Now we will give input and output in the code. So we will not giving in this. If you are giving in this also, it's acceptable. So now go to click yes. Now create one file in simulation. So make sure you will set a stop. Yeah, now it will be top. Now can write your test bench code. Time scale. Sorry, time scale is important. So scale 1 nanosecond slash 1 divided by 1 picosecond. Now you will write your test bench code same as RTL module DFF TB and give us this, and then here you will not shown input and output file, just give reg clock reset and then reg D and virus Q and virus Q bar. Okay, now we mention our input and output ports, and then now we will write our logic. So first we will so this is important step in test bench. We must initiate our RTL file into our test bench. For this you can write DFF RTL, your RTL file name, and DUT is nothing but design under test, and click clock CLK clock and then reset then D and then Q. You must instantiate all the input and output. What are the variables using in RTL must be instantiated this test bench Q bar and bar. Okay, now we successfully instantiated the RTL file. For next we will initial begin. So now we will toggle the clock. Initial begin clock equal to 0 for continuous assignment. So in procedural assignment only we use non-blocking assignment. For this continuous assignment we use blocking assignment. Clock equal to 0 and forever at 5 nanosecond clock will toggle clock. So it's basic method to write clock behavior. So end, and then now we will coming to the important logic we write for our code. So initial begin reset equal to 1 bit binary 1, and then e equal to 1 bit binary 0. Initial begin reset equal to 1 and d equal to 0, and then give some delay. I will give 12 delay, and then after 12 delay reset equal to 1 bit binary 0, reset equal to 1 bit binary 0, and now after some delay d equal to 1 bit binary 0 0, so and then some delay d equal to 1 bit binary 1, and then after some delay d equal to 1 bit binary 0 again, and then give some delay and finish with $finish, and for begin this end, and then end module, and there is no error in our test bench file, so click this to save our test bench file. Here you see the RTL file will be under the test bench, which means we instantiate correctly. So and then go to simulation. Before simulation, if you want to see and take the cinematic, click the cinematic, and here you will see cinematic Q bar and our inputs, so our code will be correct. Just click this, go to test bench and click run simulation, run behavioral simulation. Yes, it will take some time to simulate. Here you will see the arrow mark will be at $finish, and go to this and see our waveform. So here initial begin, first you see clock waveform clock. So here I will make mistake in my code, so just a minute. Yeah, here before, here I mentioned q equal to invert q bar equal to invert q. This is wrong. Why means here we use procedural assignment, so this block will execute all or on same time, so the q will not updating at the same time. So here we will use d, so this will be correct. So now you can run simulation, and then yes, okay, just a minute, it launching simulation, so you can change the mistake I made before. Okay, just click OK and see the waveform. Just little bit zoom. Here you see, yeah, if d is 1, first we check clock will toggle every 5 nanosecond, so it's correct. So initial begin, our reset will be 1, so after sometimes d should be 1, and whatever in d it will be appear in q, so d is equal to 1 and q will be 1. Q bar will be inverter of q, so 0. So here you will see D will be 0, Q will be 0, Q bar will be 1. So, and then here D will be 1, Q will be 1, Q bar will be 0. So our circuit will be working fine. So it is the method to write and test your circuit in Xilinx Vivado. So thanks for watching. Thank you.